In the last lesson, we looked at special right triangles on the unit circle, focusing on the 45, 45, 90 special right triangle. In this video, we are going to look at the second special right triangle, the 30, 60, 90 triangle. And what's a little different about the 30, 60, 90 is that it actually contains two sets of reference angles. Okay. By virtue of being a triangle with two different acute angles. So if I have a 30-degree angle and a 60-degree angle, well, relative to 30 degrees, this is my opposite side, this is my adjacent, and then the hypotenuse is always the same. But relative to 60 degrees, this is actually my adjacent, and this is my opposite. And so within this 30, 60, 90 triangle, I can have a reference angle of 30 degrees, or I could have a reference angle of 60 degrees. So I get two sets that sort of have similar ratios. And those sets are, we have a reference angle of 30 degrees. And this set includes, in radians, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So it's sort of this 1, 5, 7, 11 set, all pi over 6. And in degrees, that's 30 degrees, 150 degrees, 210 degrees, and 330 degrees. So each of these angles shares a reference of 30 degrees, which we see in the 30, 60, 90. But we also have a second set of angles. We have angles that share a reference of 60 degrees. And so these angles are, in radians, pi over 3, 2 pi over 3, 4 pi over 3, skipped one, and 5 pi over 3. And each of these reference or angles that share the reference angle are in one of the four quadrants. We have a 60 degree, 120 degree, 240, and 300. And this set is that 1, 2, 4, 5, all pi over 3. And what's really interesting here is the ratios are somewhat shared for the reference of 30 and the reference of 60. And so let's take a look at that. From the diagram I drew on the left here of the triangle, we can actually see that the sine of 30 degrees is equal to the cosine of 60, because both of these ratios are this side to the hypotenuse. We're describing the same side relative to hypotenuse. It's the side opposite 30 or the side adjacent 60. So the sine of 30 is cosine of 60. We'll also have that the cosine of 30 must then, and let's change this color actually, cosine, not that one. Cosine of 30 is going to equal sine of 60. And that means the adjacent relative to the 30 to the hypotenuse is the same as the opposite relative to the 60. And then there's one more relationship where tan of 30 degrees is going to equal cotan of 60, where tangent is opposite to adjacent and cotan is adjacent to opposite. So those are going to be equivalent. And then to build this out a little bit more, let's look at our 30, 60, 90 triangle. So I'll draw one here. And remember, I sometimes call it 2y, 1y, and y root 3. You can use that however, or 2, 1, and root 3 are the sides, assuming that the angles are 30, 60, 90. So that's the ratio they exist in. However, on the coordinate plane and on the unit circle, we actually have a triangle. Well, that's supposed to be a 30, 60, 90, where the ratios are 1, because the hypotenuse is a length of 1. The ratios are the same, but that means this side length opposite 30 has to be 1/2, and the side opposite 60 has to have a length of root 3 over 2. And so from that, we can build out our trig functions. So we can say sine of 30 degrees is equal to 1/2. We can say cosine of 30 degrees is equal to the square root of 3 over 2. And tangent of 30 is equal to, well, that would be 1/2 over root 3 over 2 multiplied by the reciprocal, and we'll eventually, when simplifying, get root 3 over 3. And then on the other side of things, if we look at the 60-degree angle as being our reference or our theta, we have sine of 60 is equal to root 3 over 2. We have cosine of 60 is 1/2. And we have tangent of 60 is equal to, well, this is just the square root of 3, if you do out the math. But importantly, I want to highlight that the sine of 60 and the cosine of 30 are the same, right? Just like the sine of 30 and cosine of 60 are the same. And those are the ones you really need to focus on. The tangent is whatever, but sine and cosine will really get you everything, because sine and cosine, remember, correspond to the x and y coordinates of the place where the angle intersects the unit circle on the coordinate plane. So let's take this all to the unit circle and get to work. So I'll keep those handy in view, and let's do a little graph here. We'd like that to be up a little bit. We're going to start with our 30-degree set. Okay, so I'm going to draw an angle in standard position of 30 degrees, or pi over 6 radians. And we'll look something like this. And let's call that 30 degrees, or pi over 6 radians. And let me draw a unit circle to go along with all this. And let's just put the unit circle, pretend it's this, and hope that's good enough, close enough. And from this unit circle that we have here, I can say that the x, comma, y, the x and y coordinate, we know that the x is going to be equal to the cosine of 30 degrees, or pi over 6 radians, and that the y is going to be equal to the sine of 30 degrees, or sine of pi over 6 radians. Okay, and we just calculated that a second ago. The sine of pi over 6 is just 1/2. So my y-coordinate is going to be equal to 1/2. And my x-coordinate is square root 3 over 2. And that came from this triangle over here, which is the exact triangle we have if we draw it in on this coordinate plane. We have a hypotenuse 1, a opposite of 1/2, and a adjacent of root 3 over 2. And so putting all that together, we end up with these coordinates. And so that's going to be our reference angle of pi over 6. When we fill in the rest of the crew, so let me add in here, we'll do a slightly darker green. If I put in my new angle, 5 pi over 6 radians, and I want to know the x comma y, well, the x is going to be cosine of 5 pi over 6, and the y is going to be sine of 5 pi over 6. Okay, and we know that that's going to be the same as the reference angle, just changing the sign for the quadrant. So x is going to be negative in this quadrant, so my coordinate is actually going to be negative square root 3 over 2, and my y-coordinate stays positive in quadrant 2, so comma 1/2. And so that tells me that those ratios are equal to negative root 3 over 2, comma 1/2. And that's for this angle of 5 pi over 6 radians. Continuing on, we can build to the third quadrant angle that shares a reference angle of 30 degrees. That is going to be our 7 pi over 6 radians. And this is going to have a coordinate x comma y of negative root 3 over 2, comma negative 1/2, because it's the same as the reference angle, but now we are in this minus minus quadrant where both x and y are negative. And then our last one, let's see if we can get one more green type color, is going to be the quadrant 4 angle that shares the reference angle of 30 degrees. And that is going to be, let me just draw it a little better, that is going to be 11 pi over 6 in radians, or 330 degrees. And so our xy coordinate, we still have the same ratios. It's going to be root 3 over 2, but our y is negative, negative 1/2. And so this entire set of root 3 over 2 1/2, negative root 3 over 2 1/2, negative root 3 over 2 negative 1/2, root 3 over 2 negative 1/2. That is all coming from the reference angle of 30 degrees, and that gives us the ratios that allow us to calculate all these different trig functions. And so for you to memorize, or my recommendation to memorize, is this 1/2 and root 3 over 2. This is the one that you really want to know for 30, 60, 90. Compared to before, 45, 45, 90, you really want to know root 2 over 2. So make the effort, memorize these ratios, and you'll be in a really good position to be able to do trig without a calculator for all these special right triangles. And so how can this be used? One way I could use this to do this math without a calculator is, say I wanted to calculate the sine of 5 pi over 6. And I'll walk you through my thought process. So I know that 5 pi over 6 is in the second quadrant. So I say quadrant 2. And then I know that it has a reference angle of pi over 6. And I know that the sine of pi over 6, or sine of 30 degrees, is 1/2. And in quadrant 2, sine is still positive, the y's are still positive, so my answer is just 1/2. So I'm able to reach this conclusion thinking about the unit circle, the reference angle, and the ratio. Now say I wanted to calculate the cosine of 5 pi over 6. I would go through this same process. I say I'm in quadrant 2. I have a reference of pi over 6. Cosine of pi over 6 is root 3 over 2, but since I'm in quadrant 2, my x-coordinate is negative. Cosine goes with the x, so it would be negative root 3 over 2. Okay, let's do 2 more examples here. So let's say I want to calculate the sine of 11 pi over 6. So my thought process goes, first, it is in quadrant 4. It has a reference angle of pi over 6, or 30 degrees. The sine of pi over 6, or 30 degrees, is 1/2. And so if we are in quadrant 4, the sine, which corresponds to the y-coordinate, is going to be negative. So this must be equal to negative 1/2. And if we look at our unit circle to verify, we see that that's true. If I wanted to calculate the cosine of 11 pi over 6, I go through this same process, quadrant 4, reference angle, ratio. X is positive in quadrant 4, so it must be positive root 3 over 2. And so this is how you're going to be able to do these different calculations in your head. Sine of 5 pi over 6, or all these ones that come from the special right triangles, the 30, 60, 90, and it's set. So now my question to you is, what's going to happen? What will happen for the 60-degree angle set? Okay, the angles that share a 60-degree reference angle. And so that's in radians, pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. How will this compare to what we just did? Now, the similarity is all the xy's are going to still be positive and negative in their respective quadrants, but the ratios are going to switch. So positive or negative x or y is still controlled by the quadrant, but the ratios from x and y switch or flip because it's the same triangle, right? It's a 30, 60, 90 triangle. And so now we're just looking at it from the 60-degree angle instead of looking at it from the 30-degree angle. Because before we were saying, okay, let's look at this as 30 degrees, 60 degrees, and 90 degrees. And we were looking like, oh, here's our opposite, here's our adjacent. Now we're considering it from the perspective of 60. So compared to 60, this is our adjacent, this is our hypotenuse still, and this is going to be our opposite. But the numerical values are the same. It's 1, 1/2, and root 3 over 2. It's a little easier to see if we imagine flipping or turning this triangle so that now the 60-degree angle is in its orientation we're more familiar with on the coordinate plane. We have 1, we have 1/2, and we have √3/2. And so now the sine ratio is going to be √3/2, and the cosine is going to be 1/2. So let's go ahead and do that out. We will draw a coordinate grid. We'll put a unit circle on it. And we will see how this compares. So let me draw a reference angle, and let me draw this quadrant 1 angle in standard position of 60 degrees, aka pi/3 radians. Okay, so here's 60 degrees, or pi/3 radians. And based on that, I'm positive, positive. And from my 30, 60, 90 triangle, which I'll draw here, my opposite is my y, my adjacent is my x comma y coordinate here, x comma y. Recall that the y is simply going to end up being the sine of 60 degrees, and the x is going to be cosine of 60. And that's because the hypotenuse is 1, so adjacent over 1, opposite over 1. And yeah, so when we do this out, if I put my ratios in, the 30, 60, 90 has √3/2, and it has 1/2 relative to that 60. And so we get our coordinates. Now, that's going to be exactly the ratios we had in this chart here, and they're just going to be the flip of each of these ratios for 30 degrees. And so let's just build this whole unit circle out and take a look. So for the 60-degree angle set, that could be better, but oh well. So draw our unit circle, and we're going to start. So we'll have 60, doesn't like it, probably as much as we don't like it. All right, 60-degree reference angle here, okay, pi/3. Our coordinates of intersection are then going to be 1/2, comma, √3/2, where 1/2 is going to be cosine of pi/3, √3/2 is going to be sine of pi/3. We build our second one. This is 2 pi/3. Same coordinates, the sign just changed, -1/2, and then √3/2. Our third angle, quadrant 3, negative, negative, so -1/2, -√3/2. And in quadrant 4, we have, sorry, I should have said this is 4 pi/3, and this is 5 pi/3. And we have coordinate here of +1/2, -√3/2. Okay, and so again, the whole idea here is now that cosine of any of these angles, cosine of pi/3 is 1/2, or cosine of 2 pi/3 is 1/2, compared to before it was sine of pi/6 gave you 1/2, or, sorry, this should be negative. And sine of 5 pi/6 gave you -1/2. So you see the relationship between the sine and the cosine because now we've changed our perspective. Okay, yeah, and maybe a couple other examples I could do, like if I wanted to calculate the sine of 4 pi/3, well, I can see here that it must be the y-coordinate, -√3/2, because it's, well, basically everything we've done. If I wanted to do a more interesting one, sine of -4 pi/3, so now I'm starting here, -4 pi/3 is going to bring me back this way. And so it's actually going to be +√3/2. But because it's really the denominator that you kind of want to look out for, like this 4 pi/3, like kind of tells us we're in this set of reference angles, and then we just need to figure out what coordinate we're in. But this is our reference coordinate, sort of. Do one more. Let's say cosine of 5 pi/3. And so my reference angle is obviously 5 pi/3, pi/3. Cosine is the x-coordinate. We're in quadrant 4, so it is just positive 1/2. So this is how we can apply that. And to put it all together, I'm going to build a full-on unit circle. So let us draw, let's try to make a nicer set of axes this time that are more horizontal, less crooked. And let's put a circle, and we'll do it in blue. I really ought to make it more circular so it's not so off-put. There we go. And now I'm going to build out the actual unit circle with all the special area triangles. In coordinates we might know offhand. So first off, we have our 1, 0, because we have 0 and 2 pi. We have pi over 2, that is our 90 degrees, and we have the coordinate 0, 1. Remembering that these coordinates are the sine and cosine ratios of that angle. We have pi, which is at -1, 0, and we have 3 pi over 2, which is going to be the coordinate 0, -1. All right, let's start filling in more. So let's get our 30-degree angle, and that's going to intersect. 30 degrees is pi over 6, or 30 degrees. That's going to intersect at the coordinates √3 over 2, comma 1/2 by 30, 60, 90. We have our 45, 45, 90, and so that is our pi over 4, or our 45 degrees, intersects at the coordinate √2 over 2, comma √2 over 2. And we have our 60-degree angle. So that is going to be pi over 3, or 60 degrees. And that's just the flip of the pi over 6, or the 30 degrees. Same triangle, but we're just looking at it from a different side. So 1/2, comma √3 over 2. And now that we have this filled in, we can fill everything else in just by taking the appropriate signs for the appropriate quadrants. So if I want to build out this angle, this could be 2 pi over 3, or 120 degrees. My coordinates are going to be -1/2 and √3 over 2. Matching these, but just with the proper negative for the x-coordinate for quadrant 2. I'm going to build my 45-degree. And this is going to be a -x, -√2 over 2, and √2 over 2. Reference angle is 45. The actual angle is 135 degrees, or 3 pi over 4 radians. And then our angle that shares the reference of 30 degrees, which is going to be 150. It's 30 degrees off the axis, which is also 5 pi over 6 radians, 150 degrees. And this time we are going to have -√3 over 2 and 1/2. And so you'll notice quadrant 2 has the exact same ratios. All the x's are negative, all the y's are positive. And we can keep doing this, and I guess I will, just for the heck of it. So if you find this valuable, keep watching. We're going to go into quadrant 3. That is our next one. We are 30 degrees off the x-axis in that direction, so putting us at 210 degrees, or 7 pi over 6 radians. Our coordinate, we are now negative, so it's -√3 over 2, comma -1/2. Right, that matches our reference angle. Now the 45-degree angle. Now that's going to be the 225, 2 plates, which is also going to be the 5 pi over 4 in radians. And that's still just √2 over 2, √2 over 2, but in quadrant 3, they are both negative. And let me do a little highlighting. So we'll say the 45s are going to be in yellow. That's set. Let us make the 30-degree set in this light blue tealish color. So these angles all share a reference angle. And I'm thinking maybe like a little green. Do we like that green? Let's see. Yeah, why not? It's not that different though. Maybe maybe this is good. Sure. So that's our 60 degrees, which I haven't done yet in the next quadrant. So here's our 60-degree reference. That is going to be 60 degrees off the x-axis of 180, so that's got to be 240 degrees. And in radians, I believe that is 4 pi over 3 radians. Intersection, we match the coordinates, so we have 1/2 comma root 3 over 2, but we are in quadrant 3, so they're both negative. Let's get its highlight. Our next one's also going to be 60 degrees off the x-axis, just in quadrant 4. And that's going to put us at 300 degrees, or 5 pi over 3 radians. Our coordinates are going to match again. It's just going to be 1/2 comma negative 3/2, because the y is negative, not 3/2, root 3 over 2, excuse me. And we'll do our red highlight. We will go ahead and do our 45, 45, 90. And that's the reference of 45, and now we're at 315 degrees, 3 plates, pretty massive, and that is 7 pi over 4 radians. Again, we have our root 2 over 2 as the only ratio to think about, because it's an isosceles triangle with the 45, 45, 90, but our y-coordinate is negative in quadrant 4, so we put our negative. And that one was our nice blue, teal color. And our last angle, finish out our unit circle. 30-degree reference. Let's get that yellow highlight. Yeah. So that is going to be 30 degrees off the axis. That's going to be 330 degrees, or 11 pi over 6 radians. Coordinates are going to be same as the... Oops, I got the colors wrong. You didn't correct me. Or maybe you did. I don't know. So my yellow highlight, this is the correct color for the 45s. And then we'll get our teal for the 30 degrees. So then looking again at that, we have root 3 over 2, comma 1/2, but it's negative 1/2 because we are in quadrant 4. And now there's our beautiful unit circle. I'm even going to add like a little light green. Do we have a lime or green? Yeah. I'm going to do this green for the axes, because those are also kind of important. Those coordinates 1, 0, negative 1, 0, etc. And there's our unit circle. And so this is basically our reference, and you can come up with these all by hand without a calculator by using special right triangles. Recall, this is just special right triangles, right? There are still infinite points on the unit circle. Okay, there's still infinite points on there. But these are the ones you would be able to find without a calculator, and that you're responsible for knowing without a calculator. And you want to be able to recall that sine of the angle theta is going to be equal to just y. Cosine of theta is going to be equal to x. Tan of theta is going to be equal to y over x. And you want to know why that is, how it relates to the triangles. And yeah, that's really the summary of the unit circle. So hope you enjoyed this video. Hope you find it helpful. Thanks for watching.